This video is on new dams built near the Indus River in Pakistan. This was an exploratory project, so I'm going to describe the process I went through and describe the results. Before I get started on the actual presentation, I wanted to take a minute or two and talk about Pakistan in general, because this is a country that is in the news a lot, and I've been concerned that people maybe have just one impression of the country and of everyone who looks like they do. So first, I wanted to point out that as the news portrays, there actually is a lot of violence in Pakistan, and very often it's directed towards minorities. One example is a Muslim ethnic group called the Hazara. They experience frequent attacks. Then there's also attacks against Christians, the worst happening in 2013 when a big church was blown up in Peshawar right after a service. If you remember, Peshawar is also where 132 schoolboys were killed in December 2014. There's attacks against Shia Muslims, and there's actually been a series of attacks in January and February of this year. This is a Pakistani imam who was featured on the BBC Arabic because it was his dream since he was a child to start an interfaith mosque between Sunni and Shia, and so he started it in November 2013. The other man is a professor in Pakistan who was commenting on the project, and he said he thinks the interfaith mosque is a good idea, but that it won't work because when Pakistanis of different backgrounds get together, they just fight. And this is a police officer. He was killed protecting the American consulate in Karachi in September 2012. That was when the American ambassador in Libya was killed, and there were big protests in many countries. I wanted to bring this police officer up because even though he died, he's basically forgotten anyways, and his name just gets besmirched along with everyone else. Finally, this family was out gathering okra on their farm when a drone hit them. The grandmother was killed, and the 9-year-old girl and 13-year-old boy were injured. When they recovered, they actually traveled with their dad to Washington, D.C. at the invitation of a congressman from Florida to testify about the effect of American drones in the U.S. Capitol building. And this last picture is an overlook of the capital of Pakistan. This is all happening in a country that is among the most water scarce on Earth, meaning that they are close to the 1,000 cubic meters of renewable water resources per person, which is considered getting to the lower limit. The place where much of their water supply comes from is the Indus River. Indus is originally a word from Sanskrit, and it means trembling water or trembling river. And in Pakistan, this river is called Sindh. And you don't actually need country boundaries to be able to spot Pakistan from the surface of the earth. You can tell where it is based on how green it becomes around the Indus River and the rivers that flow into it. My project was to take a look at the dams that have been built in Pakistan within the past 15 years. And by look, I mean using satellite images to look at them, to see if those dams caused changes in the rivers. From here on out, I'm going to take you through what I did. First, some background about dams. The first major dam on the Indus was built in 1913, and then there were a couple of others built by the British during the Empire days, and then many more were built during the 1960s and 70s after independence. Some of these dams are for drinking water, but the vast majority are for irrigation of farms, including every single one of the 25 dams built after 2000. These are the ones I want to focus on. This was a critical time, because since 1980, Pakistan's population has doubled, and in addition to being classified as water scarce, they have a lot of malnutrition and stunted growth amongst children. So even as they dam rivers to use the water to grow more food, that hasn't solved their hunger problem, but it is worsening the strain on their few water resources. And I got a list of 25 dams from the Food and Agricultural Organization, but I only found a couple of them on Google Earth, so those are the 5 which you see right here. Now, I mentioned that I wanted to use satellite imagery to see how dams cause changes in rivers. The main change I was looking for was whether the rivers become narrower downstream from the dam. This is because when a dam is built, it coops the water up in a reservoir for human use. It lessens the flow downstream, and so plants start growing on the riverbanks, and then the river becomes narrower. Here is the satellite imagery I used to study the dams. These all come from a satellite called Landsat 5. When Landsat 5 data gets beamed back to Earth, it comes as 7 bands, and you can mix them up to see different things. For example, if I combine the blue band, near-infrared band, and the shortwave infrared band, bands 1, 4, and 7, then you get a pretty good view of what is water, what is green, and what is sand. What I can also do is to divide the near-infrared band by the red band, and wherever that ratio results in really high values, that's a sign of vegetation. It's called a vegetation index. And finally, and this was what was important for this project about dams, if you divide the difference of the shortwave infrared band by the sum with the green color band, you get an index for water. The brighter the color in the water index, the higher probability it is that there's actually water on that spot. Here again are the 5 dams. I'm going to start off by focusing on the Mial Dam, which was built in 2004. In the pink images, the top image is before the dam was built and the bottom image is after. You can clearly see the blue mark where the dam formed. And then, these black and white images are the water index that I just mentioned. The water index images are again showing before and after the dam being built, and it shows both where the dam is and the river downstream from the dam. And remember, I wanted to see whether the downstream section had become narrower after the dam was built. However, it turned out that for each of the 5 dams I looked at, the water index could not for a single one detect water before the dam was built, either at the dam or downstream from the dam. The river before the dam was built was just too narrow for the Landsat 5 satellite to detect water there. Since that was the case, it wasn't possible to do the original comparison that I had intended. Since the original plan was scuppered, I decided instead not to look at the river downstream from the dams, but at the dams themselves, because the dams are actually detected in Landsat. So here again is the Mial Dam, and first we'll just look at them visually. And then I made a water index for each of the 5 dams based off of 28 Landsat images over time. When the water index is calculated, all the values end up being between -1 and 1. And the closer the value is to 1, the more likely it is that there's water there. So I experimented, and I finally chose a threshold of 0.2, meaning any water index value that was above 0.2 got counted as water. And then, since each pixel is 30 by 30 meters, I just converted each pixel into kilometers squared, and these are the values on the graph. This graph is basically just showing the water surface area of each of the 5 dams for about a 4-year period. And this is based on all the Landsat 5 data that was available for this area. And the green bar in each graph is showing when a really big flood hit Pakistan in August 2010. So if anyone wanted to study this further, I would suggest that they study more in depth how the dams respond to the sunny season and the rainy season, which you can also see on the graph, and how the different small rivers are connected to each other, and if there's any better way to collect the rainwater from the big monsoons so that it can be available during the dry season and relieve some of the water scarcity.